Before ReLU, activation functions like Sigmoid and Tanh used complex exponential math. ReLU replaces this with a single rule: take the maximum of 0 and the input. Functions like Sigmoid and Tanh work well near the center, but their gradients become very small as the input gets larger or smaller. As the signal passes through many layers, it keeps shrinking, making deep networks difficult to train. ReLU was introduced to solve this problem by allowing gradients to flow much more effectively. ReLU curve is incredibly simple. If the input is less than 0, the output is 0. If the input is 0 or greater, the output is exactly the input. That means the graph is flat on the left, a straight line on the right, and has a sharp corner at the origin. One of ReLU's biggest advantages is that it doesn't saturate for positive values. The gradient stays equal to 1, allowing learning to continue even in very deep networks. However, there's one drawback. If a neuron keeps receiving negative inputs, its output stays at 0, and its gradient also becomes 0. This is called the Dying ReLU problem, because the neuron may stop learning altogether. Let's calculate a few examples. If the input is -5, the output is 0. At -2, it's still 0. At -1, it's 0 again. At 0, the output is 0. At 1, the output becomes 1. At 3, the output is 3. And at 5, the output is 5. It's simply 0 for negative inputs and unchanged for positive inputs. Now for the math. ReLU is defined as the maximum of 0 and the input. In piecewise form, it outputs 0 when the input is negative and outputs the input itself when it's positive. Its derivative is 0 for negative inputs and 1 for positive inputs. Since ReLU doesn't use exponential calculations, it's much faster and more computationally efficient than Sigmoid or Tanh. To overcome the Dying ReLU problem, several improved versions were introduced. Leaky ReLU allows a small negative slope instead of becoming completely flat. ELU, or exponential linear unit, also keeps negative values active while providing smoother learning. These variants help prevent neurons from becoming permanently inactive. Let's recap. ReLU is simple, fast, and one of the most widely used activation functions in deep learning. It avoids the vanishing gradient problem for positive values, making deep networks much easier to train. Its main weakness is the Dying ReLU problem, which variants like Leaky ReLU and ELU are designed to solve. Follow the daily deploy for more AI and deep learning concepts explained visually.